Children, in this video I am going to teach about n plus L rule. What is n plus L rule? N means you know principal quantum number. L means you know azimuthal quantum number. In the previous videos we have learned shells, subshells, what is the number of the shell, how many electrons present in the shell, subshell, everything clearly we have seen. So if you are taking a hydrogen atom, the energy of the electron present in that atom already we have studied minus 1312.8 into Z square by N square kilojoule per mole. So the energies of the various orbitals is given as like this. First oneness greater than 2s 2p, then 3s 3p 3d, then 4s 4p 4d 4f, then 5s 5p 5d 5f, then 6s 6p 6d 6f, then 7s, like this going on. This is the order of arrangement of the orbitals as like we have learned the previous videos. So the electron in the hydrogen atom occupies the oneness orbital because hydrogen having only one atomic number, having only one electron. If it occupies in the oneness orbital, it has the lowest energy, that is called as ground state. So ground state has the lowest energy. Now here after this electron gains some energy and it jumps to the higher energy levels like 2s 2p, and these states are called as excited states. Ground state, excited state. When the electron, if it is in the ground state, it has lowest energy. If it jumps to the higher energy level, it has the higher energy, so they are called as excited state. But the above order is not true for other atoms, for multi-electron atoms. Multi-electron atom means having many atoms. So for such systems, the Schrödinger equation is quite complex. So for that systems, the relative order of energies of various orbitals is approximately given by the rule called n plus L rule. The rule followed here. So what is the rule? First rule, the electron are filled in which n plus L value is lower. This is the first rule. Second rule, in an orbital, if two orbitals have the same n plus L value, same for two orbitals, find lower the value of n, then that orbital is filled first. Now I will give two examples. See 2p, take 2p orbital and 3s orbital. N, L, n plus L. N means principal quantum number, L means azimuthal quantum number. Here 2p, 2p means n means 2. L value for p orbital is always 1. So n plus L, 2 plus 1 equals to 3. Take 3s. N value is 3. S orbital always having L value 0. So 3 plus 0 equal to 0. Both getting equal value, N plus L value. If both the orbitals having equal value, now see the N value. N value here which is having the lower value of N, 2p. So 2p is first filled up, then comes for 3s. That is the N plus L rule. Now suppose you take 1s and 2s. N, L, N plus L. What is N here? 1. S value for L value for S is always 0. So 1 plus 0 equals to 1. Consider 2s orbital. N value is 2. S always having 0. So 2 plus 0 is equal to 2. The values are different. Now N plus L value which is having lower, 1s. This is the first rule. So 1s is filled up first, then comes the second layer. This is the rule 1 and this is the rule 2. If N plus L value for both of them is same, see the N value. N which is having lower, that should be filled up. This is the 2 rule. Based upon this N plus L rule, this order is changed somewhat. 1s, 2s, 2p, 3s, 3p, then 3d comes. Now no, 3p, 4s, then only 3d, then 4p, 5s, 4d, 6s, 4f, 6p, 4f, then 5d, 6p, then 7s, then 5f and so on. This is the N plus L rule. So here the s orbital, that is the net charge experienced by the electron is called as effective nuclear charge. What is effective nuclear charge? The charge experienced by the electron. So the effective nuclear charge depends upon the shape of the orbitals and decreases with increase in azimuthal quantum number. So greater the effective nuclear charge, greater is its stability. So the energy of the orbitals may be like this: S, then P, then D, then F. S is the having greatest energy because it is near to the nucleus. Now Px, Py, Pz, similarly Dxy, Dyz, Dxz, Dx square minus y square, Dz square. These are all orbitals having similar energy. So they are called as degenerate orbitals. What are degenerate orbitals? Presence of that is the 3p orbitals, Px, Py, Pz having same energy. So they are called as degenerate orbitals. So we have learned lot in this video. One is ground state, excited state, then degenerate orbitals, effective nuclear charge. Everything you have learned is given clearly in the book, page number 50, 51 and 52.